Well, hi there, and welcome along to today's discussion. Today, we've got a really interesting topic and a great bunch of people from across the aviation industry joining us. So, just quick introductions. My name's Bevan. I'm a founding director here at blackmaps Geospatial. So, we're a aviation-focused geospatial consultancy that deals primarily in the aviation industry. My background, I've spent the last 24 years in aviation, from engineering to flying, and been flying here in New Zealand for the last 16 years. But it's not all just about me. Today we're joined by some great people, and I'm very pleased to welcome, first of all, Jayne. Jayne Marsh is the Safety Management Systems and Aeronautical Manager at Rotorua Airport. Jayne, thanks for being here today.
Yeah, thanks, Bevan.
And next we've got Julian Wicky from Aeropath. So Julian's a navigation procedure designer there and was involved in developing Rotorua's RNP-AR procedures. So thank you for joining, Julian.
You're welcome.
And last but not least, Gareth Clare. So Gareth's part of the blackmaps team. He's a very experienced pilot, as well as experience in flight ops management and procedure design. So thanks for joining, Gareth.
Thank you, Bevan. Good to be here.
Cool. So today's discussion is really part of a broader topic around this topic we call integrated aerodrome safeguarding. And that's really just about bringing all of the complex safeguarding requirements that airports face and bringing them together in one simple place. That gives us better visibility and better access to everyone from the aerodrome to airnav providers to the regulator and then to landside users. So airport safeguarding is quite complex, and some things add a bit of complexity to that, and some of that is new procedures. And so really that's why we're here today, to discuss specifically Rotorua and its new RNP-AR approach procedures. We'll talk about some of the benefits and then some of the challenges they bring. So I thought we should start with the why, and no better person to speak to the why than the airport themselves. So Jayne, perhaps you could spend a couple of minutes just explaining why Rotorua Airport commissioned the Aeropath to develop these latest RNP-AR approach procedures.
Well, thanks, Bevan. So our existing southern approach in particular had more issues with cancellations than most, due to it had very high minima. And this was because the terrain prevented an approach that was aligned with the runway. The AR approaches work much better in this environment, and even now we've noticed an improvement already. Things like better connectivity, reliability, and improved safety as well. So, and we've noticed, the other day, lots of low cloud. The terrain here, the Rotorua caldera, the airport's on the bottom of this, creates some interesting weather. And when the ground crew are just hanging around, they actually didn't think the aircraft would arrive. Normally it probably wouldn't. They were waiting there to marshal it in, and you can actually see the moment when they realise, actually today, this one's going to arrive. It's not going to divert, it's actually going to land, and you see them jump into action. So, and the human benefits are very real. Today, people are getting where they're going. It's a good day for everybody.
Absolutely. Obviously, the biggest advantage with AR is really around those operational improvements, isn't it? Everyone getting to where they want to be. And I guess that's a good time to bring in Julian. Could you just explain to us what features RNP-AR procedures bring from a procedural design perspective? What can you do with AR that you can't do with conventional procedures?
So the main advantage of RNP-AR in New Zealand is its ability to tailor flight paths to suit our very unique terrain environments. As Jayne mentioned, Rotorua, the proximity of terrain and the extended centerline and adjacent to the aerodrome has made the achievement of a runway aligned procedure to runway 36 very difficult in the past, using both conventional and PBN procedures, RNP approach. So when Jayne came to us and said, look, is there something that we can do to make this work, RNP-AR to us seemed like the logical option to support the majority of operators that can utilise RNP-AR in New Zealand. and it was really useful in getting around that terrain issue because of the ability to utilize RF legs. Radius to fix is what RF stands for, and it's the ability of the aircraft to sustain a curved path based on a fixed radius, and we can really tailor that in close to the terrain to make it more likely that we can align the approach procedure to the runway.
Great. And yeah, and I guess like you say, New Zealand and its topography um, is a really good use case. Places like Queenstown, Rotorua, where there's high terrain, and your conventional procedures, the lateral tolerances just make them difficult, right?
That's exactly right. The advantage with RNP-AR is the performance nav spec, in that aircraft that are approved to fly RNP-AR have onboard monitoring. They make sure themselves of their adherence to track. They alert the pilots to any deviation from that tracking, and that allows us to really reduce the defined area of protection quite significantly, because we know with a high degree of certainty that the aircraft will not leave that protection area. And that again allows you to reduce the amount of terrain involved in the assessment, and then allows you to really bring the terrain a lot more closer to the procedure, but in such a way that we know it's not going to cause an interaction with the aircraft.
Yeah, yeah. And you touched on what is quite an important part of AR there, really, isn't it? Is that integrity piece, isn't it? Is the
Yes.
aircraft being where it's meant to be and having a really high level of assurance that it is there, and so you can apply
Yeah, that's
different
the beauty
margins.
of anything with an RNP nav spec. The required navigational performance and the onboard monitoring means that the aircraft is uh, not just aware of its position in space, but also monitoring the accuracy of its position in space. And should it find any deviation from that, the pilot is immediately alerted, and the appropriate procedures are followed from there.
Yeah, and yeah, great. Thanks, Julian. And that's a really good segue into the other side of our AR. Once a procedure's designed, it then has to be flown. And so, Gareth, I'd like to sort of bring you in here, drawing on your experience, obviously as a pilot in airline flight ops. What are some of the features of AR that brings to the airline operation?
Well, Jane and Julian have really summarised, the really key benefits there, and that flows really nicely into what actually flight operations is. Flight operations is all about delivering passengers from A to B as safely, efficiently, and with a reliable service as possible. And without the skill sets of Julian and the Aeropath team in terms of having that design, then some of those elements are definitely challenged. And so for the flight operations side of it, there's an increased safety benefit, which is really number one. I mean, people want to fly from A to B as safely as possible. The efficiency piece and the reliability piece in a customer's mind is secondary to that safety, and also that safety piece is key for all of us here as well, for the aerodrome operator, for Aeropath, and also for an airline operator or any operator for that matter. So the increased safety comes from providing that lateral and vertical guidance to the actual runway, and this improves the stability of the flight path for the aircraft to be flown by the pilot, and this reduces the likelihood of a controlled flight into terrain. And this is particularly important at Rotorua because the previous approaches for runway 36 are offset from that runway. And that means that from a flight crew's perspective, flying the last part of that approach path is done using visual cues. We don't have the benefits of that onboard monitoring for the lateral and vertical path that Julian is alluding to. And that visual component is really is subjected to a greater challenges workload for the flight crew, especially if there's the weather is a bit inclement. The second piece in this is that lower minima, and Jayne's alluded to this, improves the service reliability because of the reduction in missed approaches. And so that gets to the operational efficiency piece. That has a benefit for the region. It has a benefit for Rotorua because you have two important elements. Customers are happy, and then there's also a flow-on effect of economic benefits to the wider region because, say, business travellers are able to connect into the region and be able to attend meetings, etc. Then the last part for AR is, in some instances, AR results in reduced track miles. And so that increases fuel efficiency. And given today, sustainability is a growing area in the aviation sphere. So it's not just about saving fuel, but there's a flow-on benefit from that fuel reduction that can come from AR in the fact that there's a reduction in carbon emissions. And depending on the organisation, the carbon bill associated with those carbon emissions can be quite sizable. So it's actually got a cost perspective, but then there's obviously that environmental piece, which is a growing area that we're all concerned about and all trying to improve, which AR does deliver that sustainability benefit.
Great. Well, thanks, Gareth. Yeah, so quite a few things there, eh? It's kind of sounding like, why don't we just have AR everywhere? Like it sounds like this golden ticket to sustainability and safety, but as we know in the real world, nothing comes for free. There's benefits, and then these benefits sometimes come with their own challenges, don't they? And I think, Jayne, today's discussion is really from that aerodrome context. What are some of the things that AR generates for you as the aerodrome operator? There's things that you have to manage that perhaps are new or you hadn't anticipated.
Yeah, it does add some more complexity to things. I think these approaches are more sensitive to obstacles and things, especially if they're near a terrain. So there's actually one area that's fairly close to one of the hills, and we need to survey that every 2 years instead of every 5. There's also a lot of development going on there as well, so we need to be very careful that that doesn't cause an issue. So we've been working very closely with them and with Julian as well to make sure that we get a good outcome for everybody. And the tolerance there ended up only being a couple of metres, so there wasn't actually much room to play with, but it works and everyone's happy. So yeah, it's all good. Another issue I've come across is that in the past, these straight flight paths, like our northern approach is straight in, that when they're fairly simple shapes, in the past, if someone comes along and says, hey, can I put my crane here or whatever else, I can actually do a rough calculation on that to work out the heights. And if it's close to the surface, that's when I would call in the team of blackmaps to do a proper survey. If it's anywhere close, do a really good job of measuring this. But if it's miles off, it's clear. But these new RNP-AR approaches, calculating it myself is actually impossible. I basically can't. And so everything has to be done by modelling. And that's where I've got great support from these guys, Aeropath and blackmaps. But yeah, this is great. That's where we need your help.
Well, thanks, team. Obviously, just quite a brief discussion, but I think we've covered some really interesting areas there. Obviously, lots of benefits, but then some other considerations, both for the airline itself and then, of course, the aerodrome. So that's all we've got time for today. I'd just like to really thank the members here for joining in this discussion, taking time out of your day. Thank you all. And we look forward to working with you again and talking again soon. Cheers.
Thanks,
Cheers.